Okay, this is a continuation of 2.5 from the last video, which was Friday. I just wanted to go over this section again because there was a little bit of trouble. What we're doing here, the idea is you have some zeros and you're trying to find the function to those zeros. But more specifically, we're dealing with complex zeros here. So let's take a quick look at the complex conjugate rules. Okay, this says complex zeros occur in conjugate pairs. So what this is saying is that if you have some polynomial f of x and it has a real, a zero that's a plus bi, then its conjugate a minus bi is also a zero. Which should make sense because if you remember from the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a, well, the plus and the minus would make it the two solutions. So for example, if one of your answers was 1 plus 3i, then the plus and minus would tell you that the 1 minus 3i is also a solution. That's what that statement is saying. So even if you had, let's say, 1 plus the square root of 5 over 2, then its conjugate would also be a solution, which was 1 minus square root of 5 over 2. And again, that goes back to the quadratic formula. So that should make sense. That's what that statement's saying. Again, if a plus bi is a 0 of the function, the conjugate a minus bi is also a 0. Okay, well, let's go back to what we know about factors and solutions. If we knew, this is just hypothetical, if I know that x equals to 3 and negative 1, if those are solutions, then we know that x minus 3 and x plus 1 are factors. Okay? Well, same idea with this. If I know that a plus bi is a solution, I can write it as factors. But all of your factors will be of the form x minus whatever your 0 is. Okay, it'll always be like that, x minus your 0, x minus your 0. So that's why when you write factors for your complex solutions, it will be x minus whatever your 0 is. Okay, this is your 0. Same thing here, this is your 0. Okay, so let's take a look at an example. Here we have, again, this is 2.5 continuation from Friday's lesson. Find all zeros of this function given that 1 plus 3i is a 0. Well, again, by that rule, if 1 plus 3i is a 0, then what should be a 0? 1 minus 3i. Good. Okay, so here's the big picture. I have this function. Okay, I have x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. If I were to factor that, I can't factor it now because it's 5 terms. If I were to factor this, it would be, there would be 4 factors. And I know that because of the fundamental theorem of algebra says there are 4 complex solutions, because of that 4 there. If I were to multiply all of these factors, then that means I would get that polynomial. Okay? Well, I already know 2 of the factors. 2 of the factors are with the 2 given solutions, x minus parentheses 1 plus 3i. I'll make that bigger in a minute. X minus 1 minus 3i. Okay, but I don't know what these 2 are. Well, if these are all multiplying, how do you think I can find these 2 factors? Or even better, you don't even have to find the two separate factors. It's just going to be one big factor. How will I find that one, this one here? If these are all multiplying, how would I find that remaining factor? I would have to divide. I would divide by this here. You would have to divide both sides. So what you're going to do is we're going to multiply these factors together so we can have just one polynomial here. Once I have this polynomial here, okay, I'm going to multiply this, the x minus parentheses 1 plus 3i, x minus parentheses 1 minus 3i. Multiply this, then divide it. It's going to give me that factor, and then I'll be able to go from there. Okay, so let me go ahead and take this out. Remember, the factors were, I'm just going to put f of x, and that's going to refer to the entire equation up here. X minus 1 plus 3i times x minus 1 minus 3i. And I'm going to multiply that. Distribute the negative. I get x minus 1 minus 3i, x minus 1 plus 3i. If you multiply that, if you can go ahead and multiply that on the side, you could do box method, you could FOIL it out or distribute, whatever you want. I'm going to do box method. So I'm going to put x negative 1 plus 3i on the side. And when I multiply this out, I'm just going to go through the motions here. When you multiply this out, all of the i's will cancel out. So the negative 3ix, positive 3ix, negative 3i, positive 3i, and what does the bottom become? That's going to become plus 9 because remember the I squared is negative 1. All right, so when you FOIL that out, again, I have your function equals x squared minus 2x plus 10. Your function equals this times some other factor. You're factoring. So you're becoming very creative with your factors. The fact that I gave you those two solutions from the beginning, you're able to find this other factor by dividing. Remember, f of x is the original problem. So I'm going to divide my function by x squared minus 2x plus 10, and that's going to give me the other factor that's missing. Okay, so we have x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60 divided by x squared minus 2x plus 10. So we'll have to do long division here because we're dividing by a quadratic. So again, the first one on the inside divided by the first one on the outside, you get x squared. When I distribute, remember you have to distribute to all, you get x to the fourth minus 2x cubed plus 10x squared. Don't forget to switch the signs to all of them. X to the fourth cancel. I get negative x cubed minus 4x squared. Bring down the 2x. And you do it all over again. First one on the inside, negative x cubed, divided by the first one on the outside. You get negative x. Distribute. I get negative x cubed plus 2x squared minus 10x. Switch the signs. X cubed cancels, negative 6x squared, plus 12x, bring down the 60, negative 60, do it all over again, and you should get negative 6, and there are no remainders because after all they are factors, which means you should get a solution. So when you switch the signs, you should see that it's remainder of 0. Okay, so what did we just find? If I can go back up, we just found that x minus 6, x squared minus x minus 6 is the other factor. So we had x squared minus 2x plus 10. Remember, that came from your two solutions, the 1 plus and minus 3i. That's where this factor came from. Well, we just found by long division that the other factor, x squared minus x minus 6, to your function, okay, that's the other factor that will make you, when you multiply, will give you your function. To help you find the other zeros, you would factor that x squared minus 6 minus 6. So when you factor, you should get x minus 3, x plus 2, and now you can find the zeros along with the already given two zeros, 1 plus 3i, 1 minus 3i, x equals 3, x equals negative 2. Okay, so this is the extra example for section 2.5. Go ahead and work on those book page or homework I gave you Thursday and Friday, 15 and 16. If you don't remember, I'll put it on my website also under assignments. Okay, thank you. Bye-bye.